All right, guys, it's me, Miss Smith again. We are going to be doing Unit 13.2, calculating and comparing compound and simple interest. Yes, we have already done simple interest, so this is review with simple interest. Okay, so let's go over. Simple interest is represented by I. We've already done this. This is which the principal or the variable P has an agreed upon interest rate represented by the percent, which is R, and it's paid only on principal over the years, which is represented by the variable T. So our formula for simple interest is represented right here. Okay, I equals P times R times T. We need to make sure that we always change R to a decimal, because it's going to be a percent in our problems. Okay, now we're going to be talking about compound interest. Compound interest is represented by A. It is interest earned is kept on the deposit to earn more interest. Compound interest is computed on the entire amount in the account, including principal and previously what your interest has already earned. Okay, so most banks do compound interest. So, and you'll see why, because it's you get more money. So most banks do this formula. Okay, so this is compound interest formula. So guys, this is really easy. You're plugging into a formula. You have to figure out what your principal is, what your rate is as a decimal, and how many years it's been going on. So you're just plugging it in just like you would do with I equals P times R times T. But in this case, you're plugging in, a different things to get a different answer, but each thing is represented the same. Okay? So with T, what is T? Very good. It's an exponent. So if we had 2 years, it'd be to the power of 2. If we had 3 years, it'd be to the power of 3. If it had 15 years, it'd be to the power of 15. So just FYI that you know that this is an exponent. Okay, so calculating compound interest. We've already done simple interest, so I'm just going to assume we got it because it's pretty easy. Compound interest is really easy. You just plug it in. So let's read our formula. Juanita deposits $50. So this is going to represent our principal in a savings account. This account earns interest at an annual. What does annual mean? Good. It means yearly, what you make each year. Okay, so annual means year. Okay, so at a yearly rate of 5% compounded annually. Okay, whenever you have a compound interest problem, most of the time it says the rate is compounded annually. So that's a clue that you know you're doing a compound interest problem. Okay, so how much does Juanita earn in interest after 2 years? Okay, so first step, just like simple interest, we're going to identify our variables in the compound interest formula. So we have A, which instead of I, A represents compound. So what was our principal in this case? Good, 50. And then what was our, we replaced 1. Make sure you put the parentheses around it. What was our rate? Good. It's 5%, so we have to change it to a decimal, so that would be 0.5 or 0.05. And then what was our time? Good, so it's to the power of 2. So now we have to change, we already did this. We changed our variable R to a decimal from a percent to a decimal by Dr. Pepper. Okay, cool. Mine's a little bit different since I'm doing a slideshow thingy, but just fill in the parts that you need, okay? It's a little bit different. Okay, so when we're actually working out, we are doing GEMS. When we're working out compound interest, we are definitely doing order of operations in GEMS. So we did not have A, because that's what we're trying to find. We had a principal of 50, and we replaced R with 5% or 0.05 as a decimal, and we replaced T with 2. So I'm going to go through each step with you to make sure that you know how to work this out. Okay, so the first step we have is 1 plus R. Okay, so I'm not going to put my principal in just yet because I'm going to work out whatever order of operations tells me to work out, which it tells me to do parentheses first. Do you agree? Yes. Oh, whoops. I haven't replaced this yet. Okay, so 1 plus 0.05 would be 1 and 500ths. Bring everything else down. Okay. Next step, it says exponents. Of course, we did our grouping, which is our G. Now we're doing exponents. So we have to replace T with what? Good. If it's for however many years. So we have 2 years. So now this really means 1 and 500ths times itself twice. A lot of kids are going to do times 2, and that is not what an exponent is. It's saying that's going to multiply the number by itself twice. So 1.05 times 1.05, let's just keep the P here because we haven't replaced it yet. So this would equal, I'm going to go ahead and do it on my calculator because it is a big number and we don't have time to do this. Okay, so it's going to be 1 and, 1.1025. That's what I would get. It's a pretty big number. Not a big number, but a longer number. Okay, so this is 1.1025, kind of messy. And now I'm going to multiply it. Okay, this is this step. I'm going to multiply it by my principal. What was my principal? Very good, it was 50, right? So we're multiplying 50, replacing P, we're multiplying 50 times 1.1025. Okay, when I do that, my answer, I get 55.125. But do we see this in money? No, it doesn't go to the thousands. We're going to round. And my answer, I should have gotten, with compound interest in 2 years, I would get $55.13. Okay, so that's how you do compound interest. Guys, you're just plugging in a formula and doing order of operations. It's big numbers to multiply by, but it's really not, it's not hard. The multiplication part might be our only challenge here because it's pretty easy. You're just replacing just like you did with simple interest. Okay, now that we know how to calculate, or should have a clue on how to calculate simple and how to calculate compound now. So we are going to compare the two. So I'm going to read the problem. Jane has 2 savings accounts, account Z and account Q. Both bank accounts are opened with an initial deposit of 100. What does 100 represent? What variable? Good, it represents with the variable P. Okay, and have an annual interest rate of 5%. So what would my percent be? Good, it's my rate, and my rate is going to be represented as a decimal, remember, by Dr. Pepper. So R would represent 0.05. Okay, then it says no additional deposits or withdrawals are made. Okay, cool. So we know that $100 has been in there. Okay, so account Z, which is going to earn simple interest, and account Q is going to earn interest compounded annually. Sorry. Okay, so right here, Z is going to be our simple, and we know that by, I already put the formula down here for you because we're trying to find I for this. And this one, Q, is going to be represented by compound interest, so compounded annually. Okay, so let's calculate this. So pause me. I want to see if you can do simple, and I want to see if you can do compound interest, and let's see what you get. So pause me. Okay, good. Okay, notice how it didn't give us years, did it? And I kind of forgot to tell you guys this. It says which account will earn more interest after 3 years. So here's our years. It always has to give you, at least, it has to give you everything but one variable. So we are missing I and A, but so we have to have the 3 if we're going to get I. So here I would do 100 times my rate, which is 0.05 times 3. So I'm going to multiply these 3 together. Now I'm going to say pause me and come back. So when you multiplied these, you should have got $15. So that's what our simple interest would earn after 3 years if I had a 5% interest with a principal of 100. Okay, now let's do compounded. Okay, so we're trying to find A. So my principal here was $100. And then I have 1 plus 0.05 to the 3rd power. Okay? So now, order of operations, I got to do this first. So this would be 1.05 to the 3rd power. and then times 100. Make sure you do the steps that we just did with compound. So this would be 1.05 times 1.05 times 1.05, and I get a really long number. So I have 100 times this really long number that I just did in my calculator, 1.157625. Now don't be scared when you get these long numbers, because we know that we can always, at the end, cut off what we don't need. So 100 times 1.15765 is going to end up being $115 and rounded to 76 cents. Wow, look at the difference. Simple interest is very simple, and we don't get much moolah. With compounded interest over